Hey everyone, this is lesson 1025 on tangents and arcs. At this point, we've talked a lot about circles. We've talked about tangents recently and arcs, but not necessarily how they relate together. So one thing I just want to remind us of, some prior knowledge that you need for this lesson, is that relationship that we talked about regarding the tangent line. So don't forget, if you have a line that's tangent to the circle, where there's one point of tangency, right? Point of tangency is that term we used before. And if there's a diameter or even a radius that intersects with that same point of tangency, then that's going to be perpendicular. The diameter or the radius, you could say, is going to be perpendicular to that tangent line. So just knowing that the tangent line is going to give us that 90-degree angle is huge in us setting up more complicated problems. All right, so that's just something to remind you of. If you didn't have that from previous notes, you might want to copy that down. Otherwise, we could go into the next problem. And really, this next problem comes from 2 or 3 problems that I'm not going to work them out with you, but I'm just using this to help us set up kind of what direction we're headed with this lesson. So many of you might be familiar with the fact that we have satellites up in space. So if you have you ever wondered how much of the planet can a satellite actually see? So we have I have a couple of satellites drawn out for us and a picture of the world, our planet. So if I'm looking at, let's see, this first satellite, and it's trying to look at our planet. The question is, what does it actually see? So obviously, if it's looking straight down, it's going to kind of see this general area. But how far can it actually see? Now, can it see something on the other side of the planet? Well, not really, right? So there's going to be some limitations to how much it can see. So if I look at, let's draw a line to represent that. So I have, let's see if I could draw this out. So it's going to be maybe somewhere around here is the limitations of what that satellite could see going in that direction. And then also, right, it's going to keep going. There's maybe more it could see in the other direction. And so this kind of looks like it's limited to this much of the planet, right? So it's not even able to see most of the planet. In this case, it almost looks like maybe 1/4 of the planet at that distance. So what happens if we take this satellite, and it moves further away, right? So how does that impact its viewability, right? So how is a satellite's distance from the planet related to how much it could see of the planet? Is it going to be the same? So if I just see if I draw a line from here to the planet, so clearly it sees kind of the same amount of space, and it's going to keep going, and yeah, it goes up into that point, but I think it could actually go a bit further, right? So there's some more of the planet that it could actually see if it's moving far away. So same thing if we head in the other direction. Yes, it could see as much as the original satellite, but it could actually go a bit further. It's going as far as it can until it really reaches that point of tangency. So we talked about that before. So this represents a tangent line. So, tangent line, where we have this point of tangency. Same thing in the other direction. we have a tangent line with a point of tangency. So you'll notice the further that satellite is away, that point of tangency now has shifted from here to here. And I wonder if we keep moving the satellite further away, then I imagine that point of tangency is going to get even further away from it. So is there a limitation? How much of the planet can it actually see? Will it ever be far enough so that it can see the whole planet? Well, there's going to be some limitations of point of tangency. So that's what we're going to look at in the next problem, is how can we determine maybe the measurement of these angles? You'll notice the size of these angles is changing. Here it looks more like a 90-degree angle, whereas here it obviously looks smaller than 90 degrees. So this is getting smaller, the angle is getting smaller, but yet this distance seems to be getting bigger. All right, so let's look into a problem that actually has some measurements, or let's, I guess, build up to that. So here I have kind of us setting up a lot of info that we need to know. And then we're going to practice this with some actual numbers. So this is the kind of the general picture, right? So we have this circle, which is kind of like our planet. And we have this point A, which is kind of like a satellite. And we have these lines that are tangent to the circle. And so points of tangency are B and D. So this is a common picture that we see. And then there's a center of the circle, in this case is C, with some random point Z on the far side of the circle. All right, so some things we need to know are that the measurement of this angle gets smaller, it decreases as the measurement of the arc increases. So I show this to you on the picture of the satellites. So as this angle got smaller, the satellite gets further away, the visibility, or how much we're able to see, gets bigger, right? We can actually see more of the planet. So if we move this point A closer, then we end up with less visibility, right? So the arc ends up being smaller. So as angle A gets smaller, arc BD gets bigger. All right, so as this arc approaches 180 degrees, right? This is not 180 degrees. 180 would be half of a circle. So if I'm looking at half of a circle is from here to here, well, what would measurement of angle A have to be for us to be able to see half of the planet, right? So that would mean this tangent line would have to go straight across, and then this line would have to go straight across. Those tangent lines would never touch, which means really it's non-existent. This angle is going to get it's going to get really small, so small that eventually those lines are going to break apart and they are not going to intersect at all. So 180, an arc of 180 is really impossible. So it's always going to be something smaller than 180, 179.9, or right, the biggest number you could think of that's as close to 180 as possible. All right, so since we understand there's a relationship there, we're going to look at this statement here that says the measurement of this angle A is going to be equal to 180 degrees minus the measurement of this arc. All right, so right away I'm giving you a method to calculate this angle, which we're calling, there's a name for this, and this is called our circumscribed angle. So circumscribed angle is this angle on the outside. And measurement of arc BD, really, if you think about it, this is a minor arc. right? So don't forget those terms, minor arc and major arc, right? Those are the two arcs that we talked about that make up a full circle. So if it's always going to be less than 180, then this would be considered our minor arc. So there's this formula, which we just said, that says the circumscribed angle is equal to 180 minus the minor arc, which is this formula right here. All right, so since that's true, I could easily rearrange this so that we switch the minor arc. If I want to know what the minor arc is, what if I know what the angle is already, but I want to know what the arc is? Well, we could rearrange this formula so it says a minor arc is equal to 180 minus the angle. All right, so they are related to each other in this way. So this is kind of the simple formula, but it could be moved around. So if you have the angle, if you already know the angle, then you should be able to figure out the arc. If you know the arc, you should be able to figure out the angle. All right, some additional information that, just to remind you, major arc and minor arc are equal to 360. So that would be arc BD and arc BZD. Those two would add up to 360. So I could give you a problem where I'm asking you, let's say I give you the measurement of this angle, and I want you to tell me what the measurement of this arc is. So then we would be able to do it. If I figure out the minor arc, then I could use that to help me figure out the major arc. All right, so that's kind of like an overview of what we're going to be practicing. It's a lot simpler when we actually try it with numbers. So let's look at this with some numbers, and this will be similar to what an actual test question might look like. So I'm going to give you one piece of information, and let's see if you could tell me some of the other info. So there's three key parts that we're looking at here, and one is this angle on the outside. Another is this minor arc, and the other is this major arc. All right, so those are three key things here. I haven't mentioned it, but if we do know this arc, it also means we know the central angle as well. And so that's, I could very easily ask you for the central angle, and that would be the same thing as the minor arc. For right now, I'm going to focus on these three, which is our circumscribed angle, which is like on the outside. So we're told we have the measurement of arc BD, which is 100. So let me identify that on the picture. So this is going to be B to D's here. And we said this is 100. So I'm just going to put let me use a different color. So this is going to be 100, right, this arc. So I already have this answer here. I'm going to fill this one in. Arc BD is 100. So the question to you is, what's the measurement of arc A? I'm sorry, what's the measurement of angle A? So I'm looking for this right here. Well, I'm trying to figure out this measurement. Now, earlier we said there's a special relationship between this angle and this arc. And the reality is, I didn't say it like this earlier, but the reality is these two, this angle and this arc, add up to 180 degrees. All right, so that means if I take 180 degrees minus the 100, it'll give me the measurement of that arc. So let me show you how this should be done. So this is really 180 degrees minus that 100 degrees, which equals to 80 degrees. So that means this angle, angle A, is 80 degrees. All right. Now the last one asks for the major arc BZD. So let me use a different color for that one. B to Z to D. Right, this is the large arc. So I mentioned earlier, minor arc and major arc, those add up to 360 degrees. So if I want to figure out that major arc, I could use 360 degrees minus the minor arc, which is 100. So this is going to give us 260 degrees. All right, so those are, we have 80 degrees, 100 degrees, and 260 degrees. All right, so you'll notice very simple. We either subtracted, most of these we just subtracted a number, and it's just knowing the right numbers to subtract. All right, so hopefully that seems easy. We're going to go through another problem, and then I'll ask you to give me the answers if you can. All right, so similar, the diagram is not going to change, so make sure to redraw it. For sure, if you're not drawing out these pictures, then all this work isn't going to mean anything. So make sure you're drawing out a circle. Make sure you're drawing straight lines. Try to use something with like a ruler or something with a straight edge, maybe your ID or something with like an index card to help you draw straight lines. So here's the same question, except I've given you the measurement of angle A. So I'm going to put that into the picture. So this is already 30 degrees. I'm looking for the minor arc, which is arc BD. And I'm also looking for, smaller. So BD, and I'm also looking for the major arc as well. So I'm looking for those two arcs. All right, so let's see if you could tell me what the measurement of arc BD is. All right, that's this one. All right, keep in mind that special relationship between this angle and this arc. So let's see if you could tell me that. All right, let's see if you got this. So the magic numbers are going to be 180 degrees minus the 30 degrees. So that should be 150 degrees. So the measurement of this arc is going to be 150 degrees. If for some reason, I'll just mention again, if I wanted this central angle, then I would also say this angle is 150 degrees as well. All right, so if for some reason I need to know that central angle for something else, technically now we do have a way to figure that out. All right, and then the last one, what about this major arc? Now that we know the minor arc is 150, what is the major arc going to equal to? So let's see if you could tell me that one. All right, so let's see if you get this. This should be, full circle is 360 degrees minus the 150 degrees, which equals to, I believe this is 210 degrees. All right, so hopefully we have those. We have 30 degrees, 150, and 210. All right, hopefully that seems easy enough. All right, that's as much as I wanted to cover in this lesson. I want to keep it nice and short. Let me know if you have any questions, and we'll see you next time.